Yeah. So the first problem said Ploy has planted a bomb in Snowden. The bomb has a timer initially set to B, and every second it will decrease by one. And when the timer reaches zero, the bomb will explode, which we don't want to happen, which we don't want to happen. And we have n tools. We can use every tool at most once. Using from this is I don't know. Okay, so it will have n tools. You can use every tool at most once, and the ith tool will increase the timer by xi. So uh, that's good. And we have been told that if the timer changes to an integer larger than a, then the timer will set to a due to bug. Not audible? Hello, am I audible or not?
It's
You are
audible.
audible. Audible.
If somebody said not audible, I don't know. Okay, that's good. So it says that if the timer goes above a at any moment, then it would be uh, set to a due to a bug. And they have just told about it more formally now. Let's see this here. So what it means is that you will be having a timer. Okay. Yeah. So you will be having a timer and it will decrease every second. What you can do is just choose some number AI, like you will be given an array AI, like array A. In the problem they said X, but I'm naming it as A. And you can choose any number AI. And what you can do is just say that timer plus equal to AI. But in case, but if timer goes above number A, like the number A which we were being given. Okay, so let's take it as X now to avoid confusion. You will add XI. So you are being given an array like array X, and you can choose any XI, which is any tool from the array. What it will do is just increase the timer by some amount. If the timer goes above A, which this A is a limit. Initially, the timer was equal to B. Then the timer will actually become A. So can I say that if I want this to happen at the very least, like here I am losing some time, which I could have any utilized better if I was using the tool when timer is equal to one. I hope like this should be very intuitive for you that I will just use the tool only if the timer is equal to one. And yeah, I will do this so that the timer plus xi is minimized. And if it is minimized and it still goes away, the loss of time will be minimum. So that's what we have to do. What I did for this problem was just have x, like for every xi, if it is greater than or equal to a, I will just change it to xi equal to ai, like a minus 1. I don't know why it's not rubbing. Yeah, I will just change it to ai or a minus 1 basically, right? Because this is the maximum benefit I can have. Any number above a minus 1 is something I cannot have as benefit. And that's what we have to do. After that, you can just say that b plus the sum of all elements of array A is your answer. And I think that most of you would have already solved it. Let's look at the code. First of all, just take up the inputs. Here also taking the inputs. And in case if like just saying that ARRI equal to the minimum of ARRI and AI like A minus 1. So if it is any larger, like if it is a value larger than that, it will become A minus 1. After that, just summing up all the elements. So summing up these elements and initially having it initialized with B to find this expression we said here. And that's our answer. So is the first problem clear? And can we move on to the next problem? Please write yes or no inside the chat.
Yes.
Okay, let's so let's look at the second problem. Jellyfish has n green apples with some values, and jellyfish has some m apples, m green apples with some values. They have been playing a game with rounds, with k rounds. The rounds are like 1, 2, 3, 4, and so on till k. It has been told that if I is odd, then this is jellyfish turn. If I is even, then it is jellyfish turn. And in their turns, what they can do is just choose any apple from their like any of their apple, any apple from the apples they have, and choose any apple which the other guy has and swap them. Or if they want, they can just skip their turn. And both of the players want to maximize the sum of values of their apples, and that uh, we have to tell that what is gonna be the maximum amount. I guess suppose you can say over here. Jellyfish, yeah. You have to tell the maximum amount jellyfish can have as the final sum of values of their apples. So it is like there are some apples which jellyfish has. Let's have them in the array A. There are some apples which jellyfish has. Let's have them in array B. And there will be k rounds. Okay. Here in the k rounds 1, 2, 3, 4, and so on. Odd numbers are jellyfish run and the even numbers are jellyfish run. So it is nothing but alternative turns for both of the players. And we have to find that if both of the players play optimally and try to maximize the sum of the values they have, at the end of the day, we have to tell if how many what's the spelling? Jellyfish. Yeah, jellyfish. So how many what value can jellyfish has have at the end? So the final sum of values of all the apples which jellyfish has. We have to tell this. Is the problem clear? Yeah, what is the maximum? Like total is gonna be the max. Since we are assuming that they will be playing optimally, so the sum of all the values will be maximum, of course. Yep. Basically, the main idea is to see what will happen. Now, there can be some greedy approaches also, but you can even do it in a little brute force way, kind of brute force. You see that all the apples which jellyfish has and all the apples which jellyfish have, uh, if it is jellyfish turn, he will always choose the apple with the smallest value from his apples and the apple with the largest value from jellyfish apple. Right? Does this make sense? Jellyfish want to maximize the sum, so he will just choose the apple with the smallest value and the apple with the largest value from the others back to maximize his own sum. And the same thing will jellyfish begin. In his turn, he will choose the smallest apple from his pack and the largest apple from the other's pack for swapping. Obviously, if I denote it by small, a variable small, and if I denote it by a variable big, so the swap will happen only if small is smaller than big. In case if the smallest apple which jellyfish has, let's say it has a value 10, and the largest apple with the largest value of any apple which jellyfish has as a value 8, then in that case, jellyfish would not make the swap. So I think this much should be clear. This much should be very intuitive as well. Now for the brute force way, what I realized was that if at any point this kind of case happens, that initially we can say over all the apples which both of them have, let's denote the minimum value as mn and the maximum value as mx. So if at any point this happens that the one who is having a turn has mn as the smallest value of his apples and mx as the largest value of the other guy's apple, then what will happen is that he will choose this and the other one will choose this. Like from his bag he will choose this and from others bag he will choose this. You will just make swap of these two values and then it will become like this. You have the largest apple now, largest value of any apple now, and the other guy is having the minimum one. And the same thing will happen when it's turn for the other guy now. The other guy is also going to pick up the smallest apple from his side and the largest apple from your side. So again, these two apples will be picked. And it will just happen like this. From this state, you will just go back to the previous state and then again to this state in a loop. K will keep decrementing every time. Right? Does this make sense? Does this stuff make sense? That at some point this thing can happen. Yes, at some point this thing can happen. Now, if whatever the value of k, I don't care if k was equal to 2000 or k was equal to 2 lakh. I don't really care about it because what will happen is that after every two states, I will come back to the state where I was initially. So what matters is what is k mod 2? Is it 1 or is it 0? What matters is whether k is even or odd, right? Because after after every two states, after every two turns, the same state is gonna be there whenever this kind of stuff is acquired. This will always happen if min of jelly is less than max of jelly, right? No, it will not always happen. It will happen only if the guy is having the smallest value of all the apples and the other guy is having the largest value of all the apples. Let's say if you just take up the case where it was just normal that this guy is having some value small and this guy is having some value large. What can happen is that you will have a transition where these two values are being swapped. Now it is the turn of the guy B, but the minimum element it has might not be small. It might be something else. And the larger guy which the largest value which the other guy has might still be different. So here you just make the swap. There is no repetitive stuff for sure. But whenever you get to this state, it will just repeat for sure. And at this point, what will happen is that just k will be even or like if k is even, at the end you will not have anything else. So uh, in that case, you will just return back to this state. If k is even, then you will just keep looping here, and at the end you will end up at this place. In case if k is odd, in that case you will end up in this state, right? And that's what you have to do. So it is pretty much like the way the approach which I have discussed here is pretty much like an implementation based approach. There can be a greedy approach as well, but I felt that this one is more intuitive to think. And if we discuss about the code for this problem, like let's see how did I implement it. Obviously, you can have different ways of implementation. First of all, I just took the inputs, and then while taking the inputs of the values of apples, I did store them inside a vector of multi-set of integers. The reason behind using a multi-set is that this thing will always be sorted. I can make up the arrays and insert operations and login very efficiently. So that's why I have been using a multi-set and not a normal set because there can be duplicates. So that's why a multi-set. And since I required two multi-sets, I have been using a vector of uh, multi-set of size 2. You will see the reason of using a vector instead of creating two different sets distinctly because creating a vector was allowing me to write shorter code, comparatively shorter code when compared to writing something like st1, st2. As here I can just say something like this. We will discuss. For every apple, I just pushed them inside the set and I just took the maximum and the minimum of all the apples. After that, since I was going to do this erase operation multiple times, I just created a lambda function. You can write it again and again if you want. But since we have to use it only twice, you can even avoid this function and write it again and again. But it's also fine. And initially, the turn is at 0, which is for jellyfish. After that, I'm just saying that as long as there are any number of rounds left, k is the number of rounds we have to play. So as long as there are any number of rounds left, we will do something. And what we do here is, right? Yeah. So what we do here is just find the minimum element of the guy who has the turn. So here using a vector of multiset is making my job easy, as I can directly say st of turn instead of making cases what if the turn is 1 or what if the turn is 0. I can just say st of turn begin to find the smallest element of this this multiset and st of turns or 1 to find to access the set of the other guy and dot r begin being dereferenced to find the largest element of the other multiset. After that, I just said that hey, if the smallest element which I'm going to pick is the smallest element uh, of the of all the apples, and the big which I'm going to pick from the other guy is the largest apple, then I know that this loop will start. So just say k and 1. This is nothing but just equivalent to saying like this line is equivalent to saying this thing. But since this is a bitwise, we are using a bitwise operator, it is faster. And in case if k was even, k would now become 0. So I'll just break here. And here I'm saying that if small is less than big, which makes sense that now I should be making the swaps. So just delete the apples initially, which initially belong to the places, and put them into the other sets. Decrement k to say that now one turn has been like one turn has been decreased, and change the turn of the turn, and then just find out the sum of all the elements inside the set and print it. So this is what I did. Uh, does it make sense? Did you understand it?
Yes, can we use set also instead of multi-set?
No, you cannot use a set because unless it is being mentioned in the problem that there will be all distinct elements. Like the thing is, if there are any duplicates, in that case, it will fail, right? If there are any duplicates, it will just erase the other guy.
And can we say that if the k is even,
Yeah.
that doing the operations two times or even number of times is same?
Yeah. If you do it two times, it will not change anything. You do it four times, six times, eight times, any number of times, any number of even times. So it won't change anything. That's why we have been doing k mod equal to 2. That just remove that uh, even component. Yeah, I can repeat the whole stuff once again. So we just took the inputs of enemy nk. Yeah, I will discuss the time complexity also. So here we just took the inputs. After that, I declared some things like the minimum maximum element and a vector of multi-set of integers and the vectors in which I will be storing the inputs. Then I just took the inputs here. I stored the values into multi-set, into my multi-sets, and I just kept track of the minimum and maximum element. After that, I said that let's say it is turn zero. Like this turn will tell me if it is zero, it means it is jellyfish turn, and if it is one, it means it is jellyfish turn. But for both of them, the logic is exactly the same. Like both of them will do the same thing. They will see the smallest element from their set, the largest element from the other guy's set. And in case if the smallest element which you are choosing and the largest element which you are choosing are actually the smallest and largest element of all the apples, then you know that you will be going inside a loop. Since k is very large in the problem, k is very large. So we have been like we cannot run up a for loop for k size. That's why we have been saying key just remove all the even component and break in case if k is equal to 0. After that, we have been comparing if the smallest element is smaller than the bigger element or not. Because if this is not the case, then there is no point of making the swap. If it is the case, then just make the swap. And now update that the number of turns is one left, like one less left, and the turn should be changed. The other guy should be having the turn now. And at the end, just find out the sum of all the apples which jellyfish has. Yeah. And now see, let's see one more thing. How many times will this while loop uh, go on? So just try to see this. You will pick up the smallest element here. You will pick up the largest element from the other guy's turn and just make the swap. The minimum element could have been inside this or inside this. The maximum element could have been inside this or inside this. Let's say if the minimum element was here, it would now be here. And the maximum element, like for the case when minimum element was in this array, if the maximum element was already inside this array, then in that case, you see that you will initially be at this term and all the even component of k will be removed. So the k will just become 0 or 1, which means that we can remove k from that complexity in that case, uh, which means that the loop will be running only once or twice. Or in the other case, if the maximum element was in this place, then after the swap, when when the minimum element will be in this array and the maximum element will be in this like set not array, then in that case now this condition is holding. The it is turn of this guy and the mx is here, right? Or what could be the other case if mn was inside this? Then again there could have been two cases. Mx either belongs to this place or this place. Whatever it be the case, after the swap, like whatever element it chooses and makes the swap, whether it is this is the mx or the mx already belongs here, after the swap it will definitely be here. So again we can say that after one swap, this will be the case where you will see key minimum element is with you, with the one who has the choice to choose elements, and the other guy is having the maximum element. So again you will see key you are just at a state key the while loop was with k greater than 0 will run like once or twice. For being on the safe side, you can say that it will run less than 10 times. And for the other part, you solved it with set. The approach might be a little different then because they have not mentioned key there will be all unique values. Maybe they have been mentioning and I'm not able to see. For the approach which I've been telling, I believe that multi-set is required. If you just use a normal set, it should fail. And I think it should fail because
Mapping minimum with maximum does not, I think, multiset doesn't mean. We usually swap minimum with the maximum on both the players.
uh,
Only two elements are included in the operation, I think.
no, actually the thing is, let's say if all the apples which jellyfish has, all have the value 5. So you will just have just one element in the set, whereas it should have been 5, 5, 5, 5 in the multi set. You know, this kind of difference. Because according to my approach, which I was doing, I was just adding up all the values in the multi-set team. So if you want to use a set, you will have to make some different stuff. You would have to do some different stuff, and I think that it will just overcomplicate the approach, or maybe make the approach complicated. So that's why I just simply use the multi-set. Okay, so does the problem make sense now? Is it clear? Okay, that's good. Then we can move on to the third problem. In the third problem, it tells us that jellyfish has n green apples, n green apple pieces, and every piece has weight k, like one kg, which is 1 gram, and all of them have to be distributed equally to n people. So, so let me just explain the problem here. Clearly. You will be given an array where ARRI is, oh sorry, you will get an array. This problem is back. You will get two things, n and m. N is the number of apples, and m is the number of people. Every apple has weight 1 kg, and it is constant. Obviously, in general, it should not have 1 kg weight. Practically, it cannot have 1 kg weight. Maybe I did it wrong. Yeah, they have been saying 1 kg. Obviously, it is not going to happen. And what you want is that everyone and these m people should get same amount of weight of apples, same amount of weight of apples. So we have to distribute these apples such that everyone gets the same weight. Now for distributing it, what you can do is that you can cut down this apple, like you can take an apple, cut it down into two apples with weight half. Like the weight will become half and the number of pieces will become two. But it will have a cost. It will increment your cost by one. And you have to find what will be the minimum cost to distribute all these apples equally among all the people. This is the problem. So is it clear? Yep. Distribute the apples equally among all the people. Okay, that's good. Now for approaching it, one thing which came to my mind was that what is n by m? I really care about this n by m. When I actually change it to something like n dash dot by m dash, where n dash and m dash, where n dash and m dash Okay, even before that, the thing which came to my mind was that I have n kgs of apple and I want to distribute them equally to m people, which means that everybody will get n by m number of apples, right? M by n by m kgs of apple. This is the first observation I had, like not an observation but an intuition, or maybe an obvious thing, which made me think that uh, like having 10 apples and 4 people or having 5 apples and 2 people. First of all, I wanted to see that where will, as the problem says, that if it is impossible to distribute all the finite, like if it is impossible to distribute among the people with finite number of operations, then return -1. So I wanted to think that where will I get it? -1. I thought that what if it is something like 10 by 3? 10 apples and 3 people. So everyone should get 3.3333 and so on number of apples, like this way, which is not possible for me. Infinite number of operations. Not possible in finite operations. Make sense? Does it make sense? That this should be my case where I will return -1. Now I wanted to see that how will it determine whether I should return a -1 or not. Where I saw that if it is something like 10 by 4 or 5 by 2, this part of being -1 or not -1 will remain the same. Or I can even say that 10 by 4 is nothing but whatever the answer I have for 5 by 2, just multiplied by 2 and that will become 10 by 4. Like for the answer when n is 10 and m is 4. This is something which came to my mind. And I just realized that, okay, so if I just divide n by the GCD of n and m and divide m by the GCD of n and m, I will get this n dash and m dash. And here in n dash and m dash, what I want to see, uh, which part are you asking? For which part are you saying how? Okay, so for this part, this is just, you see that if you have n apples and m people, and on the other hand, we are talking about 2n apples with 2n 2n people, or maybe you can say pn, like p is the, like any natural number, and pn apples and pm numbers. So you can say this as n apple and m people plus a group of n apple and m people plus another group of n apple and m people. And this is something like you got this problem p number of times, right? Yeah. And the intuition behind GCD was this. I would be given something like this PN and PM. And like as it struck to my mind that if I have something like N and M, just N and M, then it would be easier for me to see if this M contains only the power of 2 or something else also. Uh, yeah. At While I was thinking about this, I had already thought that in that denominator with like n by m, for n by m, in that denominator I should be having something and not like 3. Like if this n by m is something like 3.3333 and so on, if it cannot be written uh properly, like if it is not ending, if it is infinite here, then in that case my answer will be no. And something like point 0.2, which was an example actually, where n is 1 and m is 5. So something like if it is something like point 0.2, again you can try to think about it, but you won't be able to distribute it among everyone by just having that operation of dividing apple into two parts. And thus I realized that, okay, so now I want to have this n into m as something like uh, an integer plus some number x naught, which can be either a 0 or 1. I don't really care about whether it is a 0 or 1, but one of them by 2 की power 0, or sorry, 2 की power 1, let's call it as x1 then, plus x2 by 2 raised to the power 2, plus x3 by 2 raised to the power 3. And all these x1, x2, x3 will be something between 0 or 1, and so on till some x of, let's say, 32. Like, I don't know if it would actually be 32 or something. But the point is that at some point of time, it should end. If the number can be written in decimal form without having dots after it, basically I can write it finitely. In that case, it will definitely be ending somewhere. It will definitely end somewhere. If it is something like this, then I can definitely find it. For that, what I want is that the denominator should be a power of 2. I can just take up this 2 raised to the power 32 common, and we'll get something like 2 raised to the power 32 into integer plus x1 into 2 raised to the power 31 plus like you don't need to go like you don't need to have a mathematical proof. Logical proof is enough. And I was just giving you some idea that what if you want to come up to a mathematical proof. So the basic idea is that the when you say about n dash by m dash, this m dash should be a power of 2. A power of 2. How will you check if it is a power of 2? It is easy. You can just find the number of bits in its binary form. Let's say if it is 8, you can call it as 100, 1000. Yeah, this is the binary representation of 8. And you can just find out the count of 1 bits, the bit 1 inside this 8. If it comes out to be 1, then it means that it is a power of 2, otherwise it is not a power of 2. This is something you would have studied at it in bit manipulation. And with this knowledge, I can easily check if my answer is -1 or not. What I need to do is just say that, hey, find out the GCD of NNM. Let's say G is the GCD of N and M. And then I will say that if M dash is M by G, and if this M dash is a power of 2, then I will proceed. Otherwise, I will just return -1 in the other case if M is not a power of 2. And now it's pretty easy to see that I have some apples. Let's say I have these apples and the number of people who want to eat. Like I have an apples and the number of people who wants to eat are less. I can just give up this number of like some apples to everybody, right? Let's say I have 10 apples and the number of people who want to eat are 4. I can just give 8 number of apples to everyone. I can just equally distribute it. Then I will be left up with 2 apples and 4 people to eat. Here I would be required to make some cut, like use that knife which I have, right? Just say yes or no, that are you with me till now or not? Does this make sense? That if I have more apples, then I will just distribute the apples which I can uniformly, and then I will be left up with some apples. The number of apples I will be left up is gonna be equal to n mod m. Now from these apples, I can say that I know the pieces I have, I cannot give a single piece to anyone. If I have these 2 apples, I cannot give any single piece to anybody, because in that case, I will not be having an equal distribution. You can try to think of for some dry case, like you can, sorry, some test cases where you dry run it, but you will be getting to this result, where it satisfied me that I have to make cuts to both of them. Where I can say that initially I was having my answer equal to 0, but now I will increment my answer by n, that I've got this many cuts required. and the number of apples will become 4. Like the number of pieces of apples will become 4. So the number of pieces will become twice. And again, I will try the same thing. I will just say that I have again got the same problem that I have n apples and m people to eat. But here I'm sure, like initially I just checked it once whether it is possible to distribute among them or not. Now, when I know that it is possible, I don't need to check it again and again. I can just say that this is now a sub problem where I have n apples and m people to eat. Just find out their answer and keep implementing it into this answer variable. So in this case, you will be having 4 people, 4 apples and 4 people. They will distribute them. They will have 0 apples left and 4 people. So now number of apples is 0 and the answer will be this much only. Okay, does it make sense? Got it or not? Just write got it if you understood it. So let's proceed further now. Yep. The code is like this. Just I just took the inputs, then I declared like found the GCD, calculated the GCD. There is this inbuilt function for calculating the GCD. Then this inbuilt function for finding the count of the number of bits in m by g. If it is greater than 1, it means that this is not a power of 2. I'm confused why you chose GCD. Okay, so the reason behind taking GCD is just I was being given some n and m. Like I was being given some n and m. Let's take 10 and 4. Now, what I want is that I want to check whether it would be possible or not. So, uh, like the case, if I just say ki, I have 5 apples and 2 people, and 5 apples and 2 people, and I want to distribute among them. If it was the case, like it just randomly came up to my mind that if it was the case like this, then I could easily determine whether it's possible or not by just checking up whether the denominator is a power of 2 or not. But in a generic case, it will not be true everywhere. If I'm not having uh, the numerator and denominator as co-prime numbers. Let's take the example when the number of apples are 12 and the number of people who want to eat the apples are 6. So in this case, the answer should be like yes, as I can just distribute them easily without any cuts. But here I cannot determine whether it's possible or not by just checking whether this denominator is a power of 2 or not. But after making up all the cuts, like 3 is common in both of them, then I will have uh, 4 by 1. Now I can check that, hey, this one is at power of 2. This is a power of 2, so 2. So yes, I can divide it. Like you can understand it better when you try to make up all the cases by yourself. Yes. So if yes, if m is not a power of 2, then I have to print -1. This is because let's say if it is something like 10 people and 10 apples and 3 people. So the n by m, like this n by m, which should be happening at the end, everybody should be having n by m weight. It will not, it will be not defined. है ना? Not defined, not sorry. It will have an indefinite sequence, infinite sequence. It will have an infinite sequence. So in that case, my answer should be no. And then I just like came across this example, 1 and 5. I saw that what if I have one guy and sorry, 1 apple and 5 people to eat it. So again, I cannot distribute this one apple into five people by just dividing it into two. By just dividing into two, I want to be able to make them uh, like divide among them at any point. And after making up some more cases, or actually it was I was getting the intuition at that time only. But after making up some more cases, I got sure that if this m, like after making n and m 4 times, if this m is not a power of 2, then it is impossible for me to distribute these n apples into n people by just dividing apples into two parts. So what I did was to just take the inputs first, then find the GCD, find the number of bits in m by g. M by g is nothing but that m dash. So since I didn't have to use it again, that's why I didn't create any variable for it. Checked if the number of bits is greater than 1. In that case, the answer is no, and I will just print -1 and return. Otherwise, I will declare something like answer equal to 0 initially, and then run up a for loop, a while loop, that while I have some apples left, any number of apples left, I will just go on with the checking. First of all, if the number of apples I have is greater than the number of people, then just say n mod equal to n, so that I will find the number of extra apples I have, which I would have to cut. Otherwise, I will just cut down all the apples into two parts. So answer plus equal to n, and in multiply the count, like, or you can just say it to be as n plus equal to n, or you can say it to be n multiply equal to 2, as I said earlier. As every apple is going to be divided into two parts, at the end you can just print the answer, and that's it. Is it clear? Okay, great. Oops.
Sir, I have a doubt.
Yes.
In the else case, you are dividing all the apples in two parts, but it's possible like we can choose some of them and the rest of them will not be chosen.
Yeah,
So
I discussed this here, that if you decide you don't cut this apple, let's say you decide that you don't cut an apple, obviously you are going to be giving it directly to some guy then, right? If you don't cut it, you must give it complete. And if you give it as complete, you are giving more portion to someone, because you cannot give this whole apple, like give everybody one apple. Now, if the number of apples you have is less than the number of people, then you cannot give everyone one apple. And if you give one apple to any one guy, then obviously you won't be able to give everybody equal number of apples. Like you will be getting a uh, contradiction, right?
okay,
And
sir.
yeah, and you should spend some time on your own for this kind of things. Like you can ask this, but I'm saying that after this session, you should spend this time on your own for this kind of things. Though you can ask this in PCDs, it's not bad. Now coming to the D problem. The D problem is jellyfish and MEX. In this problem, what it says is that it will be given n non-negative integers, and let's say that m is a variable which is initialized by 0 at the start. You will have to make n operations. In every operation, you will just choose an element from the array, and delete it. After deleting it, whatever be the MEX of the array, just add that element to your m. Fine. Just add it. And what you want to have at the end is jellyfish should have the minimum possible final value of m if he performs the operations optimally. We have to tell this minimum value of m here. So just after reading this problem, you would be going to the test cases, and here you could notice one thing, that the max, like sum of all the values of n over all the test cases will never exceed 5,000, which is a sign that n square approach can work. And if Codeforces is giving this kind of input statements for some problem, then you can be pretty sure that it will be an n square solution, especially as this is the problem D. I had low confidence in MEX problems. That should not happen. Like MEX problems are not very hard. They are comparatively easier when compared to the combinatorics problems, as they sometimes go very hard. Or maybe like MEX problems can also go very hard at some point. Okay, so what will happen is that you will be given some integer n and an array. This array will have some values. You will have to perform an operations. In every operation, you will have two things. In every operation, delete some element, like delete any element. You have to delete exactly one element, but of your choice, and add the MEX to a variable m. For now, instead of taking this variable n, I will be taking an integer n, integer answer. I will be declaring an integer answer and have everything inside it. Okay. I want to have the minimum possible value of this answer. So the one thing which you could notice was that if you are having some values in the array, first of all, the order of elements doesn't matter. Order of elements doesn't matter. So if even if the problem is something like 210 or 120, yeah, 120 or 012 in any way, it doesn't matter in which order it is, the answer will still be the same. The answer will still be the same. So this was one observation. Now it motivates us that instead of actually storing all the elements, like what you can do is either store all the elements and then sort them. Sorting them would not change your answer, so you can consider to sort them. Though it's not required for this problem, but this is one thing which I always think of whenever I see problems where the order of input doesn't matter. Or the other thing which you could have done was to just store the frequency. Just store the frequency of every element. Frequency of all elements. So for this problem, this thing is going to be helpful for us. What we will do is just store the frequency of all the elements. Let's say I have this 120. So I will just say that, hey, CNT1 plus plus, CNT2 plus plus, CNT0 plus plus. So that at the end of running the for loop, I will have CNT0 equal to 1, CNT1 equal to 1, and CNT2 equal to 1. This is one thing, like you should do either think about sorting them or about storing all the frequencies. For this problem, it turns out to be more helpful, as at the end, if you are having some array like 2 2 or maybe 0 1 2 2 3 5 7 7 9 10 11 11 11 12 20, anything, if this element is missing, this 4 is missing, it doesn't matter which element come how many times, right? but for all the elements before it, it does matter. Are you able to notice this? That if uh, all the elements which are more than my MEX doesn't really create any difference in my answer. What I can do is just say that, hey, I have to remove these elements, and once I remove all these elements, my MEX will be 0. After that, I can just remove all these elements. I won't have any cost for removing these. Does this make sense? Okay, that's good. So as I've concluded that all the elements which are larger than my MEX doesn't matter. In the problem, it has been mentioned that this AI can be as large as 1E9, but my NE can be only as large as 5000. So can I say that if my AI is larger than equal, like as this N can be as large as 5000 only, just imagine if the values are like 1, 0, 1, 2, 3, and so on till N minus 1. In that case, my MEX will be equal to N. For any other permutation, it will either be less or equal, but it can never exceed N. So if my A of I is greater than equal to N plus 1, it will always be larger than my MEX. Because even in the best case, you can have your MEX to be equal to N, whatever you call it to be the best or the worst. But even in this extreme case, the MEX can be N. All the values larger than that will be greater. So I don't care about them. I don't care about any of those values. I can simply say that, hey, if A of I is less than equal to N, in that case, just increment the count that I found this element, just store its frequency. Now for this problem, just try to think that at any point, if there is a 4 here, you remove it, and let's say the 4 is coming once again, this 3, this 2, this 1, 5, 5, anything like this. Will you ever remove this 4 and then not remove this 4? Like if you remove this 4, does it make any sense to ignore this 4? You will see that it never makes any sense. If you remove this 4, you got the cost incremented by the MEX, right? And now if you don't remove this 4, then you just got this penalty and didn't gain anything. You know, you didn't gain anything. But if you choose the next step to remove the other 4 also, in that case your MEX will become 4. This 4 will become your MEX. And you will just increment 4 in that case. So here we can say that at any point, if you remove one element, if you remove one AI, you will remove all of the AI. This is how you can think that if you remove any one element, you will remove all the elements which have the same value in the consecutive task. Otherwise, just removing this element and not removing other elements was not beneficial for you. You didn't get any benefit. Even removing the last element would have been more beneficial. So let's say there was 1 6 here also, and MEX was equal to 7. Then instead of removing this 4, you should have removed the 6 if you were not intending to remove the other 4. है ना? So one thing is clear, if you remove an AI, you will remove all of them together. This is another thing which you could have observed. The next thing is that at some point, it could have been better for you to remove some number which is neither the smallest one, neither the largest one. It is just any middle element. It could have been better for you because if you remove this element, your MEX will become equal to that element, which will help you out while removing these elements. As an example, if you have something like zeros, like multiple zeros, then a 1 and a 2. So in this case, the best choice for you is to remove this 1. Once you remove this 1, the MEX will be 1, so only 1 will be added into your cost. And now for all the zeros which you add, like again you will have a cost of 1 every time. But if you had not removed this 1 and had gone to remove this 2, you would have got a cost of 3 here. No, sorry, you would have got a cost of 2 here, and then you would still have to remove all these elements. The basic idea is that you cannot greedily say that I will remove this element or this element. You can try to think of some greedy approaches, but every time you will get to see that it is not working properly. So what you will have to do is try out all the cases, try all the cases, which is pretty brute force. But it reminds us that we were going to have an n-square solution by looking at the constraints, and maybe this brute force could have been optimized to DP. This can be an intuition, and actually this should be coming up to your mind at least for Codeforces problems. If you wanna do them faster, you should be looking for these kinds of hints also. You should be taking hints here. Now let's try to build up a DP. As we have got this intuition, let's try to build up a DP. You see that it doesn't matter which values are larger. You don't care about the count of the larger values. You don't care about which values are larger. You just care about the current MEX. What is the MEX right now? So the second parameter will definitely, like one of the parameters will definitely be MEX. Obviously, right now just telling up directly key this will be the MEX. It might take up more time for you to think when you're solving the problem on your own. For me also, it was not this obvious while solving it for the first time. But the thing is that at this point, you see that you do require MEX and you do require the element which you are trying to delete. The element, you can say it as the number which you are trying to delete. You do care about its value and the MEX right now. So as we discussed that you will be deleting all the values at once. It means that this dp of num we can define it as removing all the values um, maybe less than equal to num of this size, like all the values less than equal to num, and with MEX equal to like this MEX with this MEX. Okay. We can define the state to be something like this, which means that something like this will hold that if you are having this num MEX, this state can be called as dp of num minus 1. Like one of the ways is that you just don't remove this element. For the current element you had, let's say you had a 4 and you had some 3s there. You just said that, hey, I won't remove this 4. I won't remove any of these 4s. Instead, I will just say that ignore them or take as if I was just going to remove 3. So in that case, my transition would be something like this. Or the other transition could have been that I remove all these 4s. Like I had only two choices. Either I don't remove any of these 4s or I remove all of these. So if I remove all of these 4s, if I remove all of these fours, I will be having something like this, that dp of, sorry, not dp of num, but the count, of this 4. When you remove this for the first time, you get the cost of MEX. When you remove it for the second time, again you get the cost of the MEX. When you remove it for the first time, for the third time, like for the final time, for the last reference, now this will become your MEX. So uh, like if you are calling it as num here, then it will be equal to count of num minus 1 into the MEX plus the current stuff, the last element, which is num. And now what will happen is that you will be having only these elements left. All the other elements now doesn't have any meaning left for you. Any element larger than MEX doesn't have any meaning, because as we discussed that it is always optimal to remove them at the end and never optimal to remove them first. So you will be removing elements inside this range only. So we will add the cost of that to be dp of uh, the element which is just smaller than num, which is num minus 1, and the MEX for that will be num, since this is the first element which like will be missing now. So this will be the MEX now. So from this we have got both of the transitions. You just have to run up it for all of them, all of the states. The num can vary from 0 to n minus 1. Why would it never be n has been discussed, that n will always be greater than or equal to MEX. Like you will never have this element. If you have this element inside your array, then it will be greater than MEX. And if you don't have this element inside your array, then there is no point of checking for it. You know. And now you can just say that just run up a for loop here for all of these. For all of them, you have the, like you can take up the state to be uh, uh, between MEX equal to 0 to 1. Obviously, some states will be not reachable, will not be reachable, but going through all the states is not going to affect your answer. I think that the notes have got a lot longer. And we have to just, like, the problem is almost done. We just have to talk about the edge case now, not the edge case, but the base case and the result. So what we can do is just find out the MEX in the array first. First of all, just find out the MEX in the array, MEX of the array. Let's say that our n is equal to MEX now. Maybe like you don't need to declare it like this. You can do the step without declaring it also. Then declare a DP with, since we have n possibilities for the first element, so of size n for the first guy, and there are n plus 1 choices, n plus 1 possibilities. So it is dp of n plus 1. The base case is just simple, that for 0, depending upon the MEX, the cost will be equal to CNT 0, like count of 0 minus 1 into the MEX. When you remove 0 for the last time, you have a cost of 0 being incremented, which you can ignore, like 0 adding or not, it's the same thing. And after that, we can say that the answer will be just dp of, like if you're not declaring it like this, you can just say it to the MEX also. Uh, this dp of MEX and MEX plus 1. whatever MEX you found in the array, you can just call it like that here. And here this MEX minus 1, this is MEX. And the answer will be the MEX minus 1. Like these are all the numbers which you have to remove. Initially, whatever array you had, there was some element missing, some element was missing. So you have to remove all the elements which are smaller than that. After removing all the elements smaller than them, you can just remove all the remaining elements without getting any cost, since the MEX will be 0 every time. So for removing all these elements, and initially the MEX was this MEX. So this will be your answer. And I know that the solution looks a bit complicated. The problem looks a bit complicated if you're not very familiar with DP. And yeah, one more thing, just listening up to my solution, like someone else's solution, is not very intuitive. You won't get the intuition by just like this. You will have to spend time yourself. So I would highly recommend you to try to think about this yourself first and then try to code it. And if you get stuck, then you can look up to my code from the description. As of now, I have not submitted the solution, so I'm just showing it in the notepad. But in the description, you will be able to find my submitted code. And the code is like this. Just take up the inputs first. While taking inputs, I declared a count variable. To be on the safer side, I declared it to be of size n plus 4. And here is n plus 5. And here I said that if the current element is less than or equal to n plus 4, in that case, increment its count so that I will know how many times it comes. Then just declaring int MEX. Basically, in this variable, I will be storing the MEX of the array and running up a while loop that as long as the current element is coming, just keep incrementing the value of MEX so that at the end I will have the MEX inside this variable. If the MEX is 0, I don't really need to do anything which we will see here. I can just directly return 0 because whatever element I delete, I will get 0 being incremented to M and my answer will remain to be 0. So I can directly return it. Now, just for the convenience of not writing MEX again and again and writing N instead of it, here we are declaring N equal to MEX. You can keep everything to be MEX if you want. Declared a DP array of size n into n plus 1, and as a base case declared like dp of dp0i equal to the count, the number of times that element has been coming into the MEX, where this second parameter I is the MEX for our state. And then after that we have been coming here where I'm saying ki, int I equal to basically going to every state. In every state, you have one choice that you don't pick this, you don't remove these elements. Instead, you remove the elements which are smaller than this. So it will be dp of I minus 1j. This will be one transition. And the other transition is that you remove all the elements. In that case, you will be removing the first, like if count I is the number of times this element has been coming. So except the last time you remove this element, for all the other times, you will be having j incremented as it is the MEX right now. The last time when you remove it, this element will be missing. So I will become the GCD. I will become the MEX. And then you can say that now you want to remove all the elements in the range from 0 to I minus 1, with I being the MEX since this element is missing now. And like just to keep things a little clean, we are just storing it inside a variable here and then saying key store the maximum inside the state. At the end, we are just returning this answer. So please confirm it once. Is the approach clear? Does everything make sense? Okay, that's great. So I think we can end this session now. And for the people who have been watching it on YouTube, Please make sure to like the session if you liked it. If you got to learn something new, then please like the session and you can subscribe to the channel also.